Let's say we try to graph y equals 1 divided by x. What is that going to do? How's that going to look? Well, I have no idea. So what could I do? Let's make a t-chart and pick some points and just see if we can get an idea of what the graph looks like. Let's say x is 1. Well, 1 divided by 1 will make y1. So we have this point. Okay, we got a point, so we know it goes through there. Let's put in another point, 2. 1 divided by 2 is a half. So if we go over 2, up a half. Well, that's a terrible half, but there we go. What about 3? Well, then it's 1/3. What about 4? Well, then it's 1/4. What's happening? 5, 1/5, 10, 1/10. This guy is swinging down, isn't it? It's getting lower and lower and lower. What if I do 1,000,000? It'd be 1,000,000. So over to 1,000,000, and then we go up just a little touch. But is it ever going to touch that x-axis? No, it will not ever touch it. It's going to get closer and closer and closer. Now, let's also look what happens if we, instead of 1, what if I did a half? What is 1 divided by a half? You have $1 broken in parts of 50 cents, you'd get 2. So when I'm at a half, I'm up here at 2. If I'm at a third, I'll be at 3. A fourth, I'll be at 4. So this line goes like this. It keeps going. It gets closer and closer to x, but it never quite touches it. So we can make a line like this and say, yo, you're never going to touch that. You're going to get closer. And notice here, even if we pick 1,000th, at 1,000th, it'll be up at 1,000. You're never going to touch that guy either. Now, in honesty, this guy also is going to be like that on that side. But the key is we're looking at these dashed lines. We want a word for those where, hey, you're getting closer and closer to it, but you're never touching it. That's called an asymptote. And that's what we're going to look at today. We're going to look at asymptotes, which is basically a line is going to approach it, but it'll never quite touch it. It'll get closer and closer and closer, but never quite touch it. So horizontal, we're going to first deal with the line back here that we had, which was this horizontal. How do we find those? We'll worry about verticals in a little bit. But for right now, we want to deal with the horizontal asymptote. So we determine the horizontal asymptote by looking at the exponents, okay? The exponents of the numerator and denominator. So here, if we look at y equals 5x to the third plus 6 divided by the quantity x plus 7, well, this guy has an exponent of 3. This has an exponent of basically 1, okay? So that's what's important. We look at the highest exponent up top, which is degree 3. The one in the bottom, degree 1. That's what's going to help us determine what it is. Now, here's what we do. We remember this crazy expression, Bobo button eats DC. Look, I do this myself. I always, when I see these and I'm trying to figure out the horizontal asymptote, I go, Bobo button eats DC. If you say it enough times, it will stick with you. It has for me for 15 years. Now, what does it mean? Well, if we look at Bobo, it simply stands for bigger on bottom, meaning the degree, the exponent in the bottom was bigger. It had more. If that's the case, our horizontal asymptote will be drawn at y equals 0, which is right on the x-axis. Okay? If it's bigger on top, bottom, there is not a horizontal asymptote. There won't be one. There's not going to be any asymptote, no horizontal asymptote. And then what about this eats DC? Well, if the exponents are the same, you're going to divide the coefficients to figure out the horizontal asymptote. Because if you have some fraction here, either it's bigger on top, bigger on bottom, or you could have exponents exactly the same. And then you'll divide the numbers out in front, which are called your coefficients. So what's the horizontal asymptote of this? Well, this was our original problem, has degree 3, and this is degree 1. So I say to myself, Bobo bottom eats DC. What is it? It's bigger on top. Which one's that? This is this guy, bigger on top. What does that N stand for? None. That means there's not an asymptote. There's no horizontal asymptote here. Okay. This is what I do every single time. Now, this is just for horizontal, not vertical, nor what we later will learn about slant, just horizontal. Next example, I got degree 3, degree 5. I say to myself, Bobo, bottom, eats, DC. Well, let's see. This is bigger on bottom. Where's that? That's this guy. Bigger on bottom, 0. That means you're going to have a horizontal asymptote at y equals 0. So if I were drawing this guy, there would end up being an asymptote right here. That guy's going to end up doing sort of like our original picture where it's doing whatever and it's approaching, getting closer and closer to that line y equals 0. All right, what about the horizontal asymptote here? Well, degree 3, degree 3. They're the same. That's going to be that what? Eats DC. Exponents are the same. Divide the coefficients. What are the coefficients? They're the numbers right in front. So it's going to be simply the line y equals, because every horizontal asymptote will always be the line y equals 6. And the other coefficient's 3. Well, hey, what's 6 divided by 3? 2. So if you and I have the graph, we're going to have an asymptote right here at y equals 2. That's what we're going to have. It's that simple. Now again, only for the horizontal, not the vertical. Only the horizontal. Vertical. The vertical asymptote is determined by what's in the bottom. Okay, consider the equation 1 over the difference of x and 2. What can't x be? So if we think of this, in this equation, all that's going to matter is the bottom. That's all that's going to matter to determine the vertical. What can't x be? X can never be 2. So when I come here to 2, I'm never going to be able to plot anything here, am I? That means there's going to be a vertical asymptote there because there's going to be a line here because you're never able to plug 2 into the equation. It won't work. So that's how we determine where the vertical asymptote is. Now, again, we're not worried what the line of this looks like right now. That's not our concern. Our concern is finding the asymptote. So the denominator determines the vertical asymptote, as we just said. So whatever x can't be, that is where the vertical asymptote is going to be drawn. So let's look at this. Again, we're not doing horizontal anymore. We're doing vertical, up and down. All I concentrate on is this guy. I'm going to say, hey, where can't x, what value is going to mess it up? Well, if I simply set it equal to 0 to figure out where that's going to mess it up, we end up obviously seeing x is 3. Now that means that at 3, it can never touch 3. 3 can never be plugged into the equation. So we draw our asymptote line right there. That's all we do. Horizontal, you simply do Bobo bottom eats DC. Easy enough. Vertical, you take the bottom, set it equal to 0 to find where that vertical line has to be because x can't be that value at that point. You never can plug it in.